Let me describe a nightmare scenario. You walk into a house, motion sensor turns on lights, lights talk to the alarm, alarm triggers AC, AC adjusts curtains, and now no one knows who triggered what. One small change, and suddenly the house starts behaving like it's possessed. If you have ever felt this way about your own code, today's pattern is for you. By the end of this video, you'll clearly understand what the mediator pattern is, know exactly when to use it, and how to implement it cleanly in C#. So your objects stop micromanaging each other and start working through a single, sane brain. This video is part of my series Design Patterns Code Like a Senior Dev, where we take real-world problems and solve them the way experienced developers actually do. Let's talk about a smart home system. You have motion sensors, lights, air conditioners, alarm systems, etc. etc. The naive approach is this. Motion sensor turns on the light, lights notify alarm, alarm triggers AC, meaning every device knows about every other device. That means adding one rule, break 5 classes. Changing behavior would feel dangerous, and debugging feels like detective work. This is tight coupling in action. And this is where experienced developer says, we need a mediator. The mediator pattern says objects should not communicate directly with each other. They should always communicate through a central coordinator. That coordinator contains the rules of interaction. Think air traffic controller, or an orchestra conductor, or a smart home control panel. Everyone reports in, one brain decides what happens next. Important note before we touch the code. This is not observer. Observer is about notifying listeners. Mediator is about coordinating behaviors. If business rules live in one central place, you're looking at a mediator. Let's dive right in. Let's jump straight into the code. We are building a smart home system where devices don't talk to each other directly. Instead, they talk to a mediator that decides what should happen next. First, I'll create interface for the mediator. This defines how devices communicate with the control panel. Notice what's missing here. There is no command and no device references. Devices just notify and that's it. Now, let's create the actual mediator, the brain of our smart home. This is the key class. All the coordination logic lives here. If the rules change, this is the only place that I touch. So there's this smart home mediator that extends smart home mediator. We have references to all the components that we have. And then depending upon what's the sender and what's the event name, we do a bunch of stuff. Now let's create our devices one by one. Let me start with light. This class does exactly one thing. It controls the light. There are no conditions, no knowledge of alarms or sensors, just light. Let's move to the next component, AC. Again, no idea why it's turning on, it just does its job. Now the alarm system. Same pattern, small, focused, no side effects. Let's create motion sensor, which would be our event producer. Now, this is the component that triggers events. Now, this is important. This motion sensor doesn't really turn on lights or alarms. It just reports what happened. Now let's wire all these together. Since I'm using one page application, I have to do it on the top. So finally, let's wire everything together. Since I'm taking advantage of single page application, I would write code on top so that it works. So we'll initialize mediator and we'll initialize it with smart home mediator. Once we have done that, we would set up everything. We have light, all wire light. and then we would assign a new air conditioner to it. Once done, we'll do the same with alarm. Beautiful. Once that is done, I'll create our sensor. That is not what I wanted to do. And then I'll pass the mediator in, which would manage all the interactions. And then I do sensor dot detect motion. All right, everything looks good so far. Let's run this. All right, so we see motion detected, lights on, and alarm armed. So what did actually happen here? So when we did a sensor.detect motion, it logged motion detected on the console, and after that it evoked notify on Mediator, sent this as the source object, and then motion detected as the event. So if we go there to the implementation, if the event name was motion detected, then the lights would turn on and alarm would get armed, which is what we saw here. So everything works. Now if I go back here, and rather than detect motion, let me do something else. Let's just go here and copy this method, again paste this method, and rather than changing this thing here, we would mimic the temperature high event. All right, so we would detect high temperature. All right, hope I spelled it right. I think I did. And then, did I paste it? Yes, I did. Okay. Well, all right, let's call this one now and see if it works. Okay, so rather than detect motion, I would detect high temperature now. And let's run the same thing again. All right, so we can see high temperature detected, AC was on, and lights were dimmed. So if we go to detect high temperature, we console log this, so that matches with this. And then we notified Mediator of high temperature here. And what Mediator did was, because the event name was high temperature, it turned on the AC and made the lights dim. That's how easy it is to implement Mediator pattern. Experienced developers reach for Mediator because logic lives in one place. The components stay small and testable. Adding rules doesn't really break the existing code. Refactoring becomes much safer. Your system stops being a web and starts being a hub. Quick warning: use Mediator when interactions are complex, rules change often, not for simple two-object communication. So today we learned what Mediator pattern really is, how it's different from observer pattern, and how to implement it cleanly in C#. This is the kind of pattern that quietly signals that the code has been written by someone experienced. If you're enjoying design patterns code like a senior dev, check out the rest of the series. We turn confusing patterns into practical tools you actually use. I'll see you in the next one.